Alright guys, good afternoon. We're going to cover today over chapter 4. This is going to be the beginning part, which is in 2D. And this is going to be I believe this is a bell crank lever or uh, very similar to that, like a cantilever beam almost. But it's homework number 4.17. Pretty sure y'all were assigned this in class and it should already be past due at this point. But basically, we're given a tension AB, which is 150 pounds, and we need to find tension DE and the reactions at C given this diagram. So to begin this, you're going to draw the free body diagram. So they stated in the problem that point C is a pin connection, so that means we're going to have two reactions, a reaction in the X and a reaction in the Y. We stated our tension, which is going away from the crank, it's at tension AB, and then tension DE is also going away because that is also being its counterproductive tension DE, and the given dimensions from the problem. So to start this, easiest way to do it, go ahead. You can do some of moments first. You don't have to do forces in the X, Y, and Z and everything first. You can do whatever method you want to do first. It doesn't matter. So I did some of the moments about C first. So when you have it pinned at C, so it means our two unknowns are gone. We have a tension AB, which is a counterclockwise rotation, so it's positive. Its perpendicular distance is going to be 5 inches because if you look at the dimensions given, it's practically a 3, 4, 5 triangle, so that becomes a 5-inch perpendicular distance. Now if you look at tension DE, it is causing a negative rotation about C, so it's going to be negative tension DE times this perpendicular distance from C to D, which will be 6 inches. After finding that, you can take your equation. Since we know tension AB, we solve for tension DE, which is also force DE. I just wrote it differently in this point. We get force DE to be 125 pounds. Now after solving for that, you can do your sum of forces in the X and the Y. Sum of forces in the X, we get negative 3/5, which is 3 over 5 from the dimensions given, times our tension AB, which is 150 pounds, plus our reaction at C in the X direction, which is CX, is equal to 0. Solving for CX, we get 90 pounds. Taking the sum of forces in the Y direction, we get a negative 4/5 times tension AB, 150 pounds, plus CY, minus 125 pounds, that's the tension at DE, it's going down, equal to 0. Solving for CY, we get 261 pounds. So this one is a good problem for chapter 4 that is in 2D, and you still have to take moments, sum of forces, everything. So this would be a pretty good beginning question that Jackson would probably give for exam 2. So I would definitely know how to do this, because if you don't know how to do this portion in 2D, then in 3D it will get much more complicated for you, as you will see in just a second when we go down to our next problem. So this problem right here, I believe, is from the online portion of the homework. So I just kind of already have it written out. So the problem states is that this is like a plank of wood or any type of like trap door kind of thing, or a ventilation door in the ceiling, for example. So they stated us that the weight of the board is 93 pounds. It's hinged at point A and point B. It's maintained in its position due to rod CD, which is also pivoted at C, so it's a pin connection. And D is also a pin connection. They also gave us that hinge B does not exert any axial force or any axial thrust. And they gave us our alpha angle, which is 50 degrees. They ask us to find tension CD, just the magnitude of it, though we don't need the direction. And then they find reactions at the hinges. So this problem is much more complicated. There's a lot more going on with it, and it's in 3D. So you just gotta take your time, go through it each little piece by piece, and we'll get through it. So in the free body diagram, we have hinge A, which exerts everything. So it's got a force in the X, Y, and Z directions. Our B does not exert anything in the X direction due to what was given, so we have a BY and BZ. We have the weight of the plank, which is our I stated as a G, which is the global weight, which is 93 pounds. And our force CD we can treat as a tension or compression style, and we just stated as force CD. So to start it all off, we'll start at for the A portion, which is finding tension CD. I did this by using the law of sines, which is sine beta over 7 inches equal to sine 50 over 15 inches. Solving for beta, we get 20.946 degrees, which is that upper portion where D is. And now we need to find our lambda, which our lambda we can just do, which is right here, is 50 degrees plus 20.946 degrees. We get 70.946 degrees. After finding that, our angle, we can start doing our sum of forces in FCD. We get FCD sine of lambda, which is in the J direction, plus FCD cosine of lambda in the K direction. Plugging our values in for lambda, we get this equation of FCD times sine 70.946 plus cosine 70.946. I just pulled the FCD out because it was a common factor. So this is our equation known. We have two unknowns, so we need to take a moment. So the first point I did was take a moment about B. This one's probably a little on the harder side to do first, but it's still going to work out just fine. It's just I want to do a little bit of a harder route just to show you that you can do it both ways. So if you take a moment about B, we need to find our, so I did the perpendicular distance times the force. So I did kind of a backwards format, but it still will be just the same. So our sum of the moment, we get a negative 26 inches times AY. So AY is going up, and if you look at B, it would be going a clockwise rotation, and its perpendicular distance from B to A is 26 inches, so it's going to be a negative 26 inches times AY. Now, AZ also causes a moment about B, and its perpendicular distance is 26 inches, but the rotation is a counterclockwise rotation, so we get a positive 26 inches times AZ. Now we need to find what our moment would be about the weight. So we have the weight, which is 13 inches, which is just half of the 26 inches, times the 93 pounds, and is causing a counterclockwise rotation about B. But the weight's also causing a moment about, I believe I have it as the Z direction. But so the perpendicular distance from B is right here, half of 32, which is going to be 16 inches times 93 pounds. But it's at an angle because it's the same angle from over here, which is our lambda. So we take it as cosine 50, which is actually our alpha that they gave right here. And then we have negative 26 inches times FCD sine of 70.496 plus 26 inches FCD cosine 70.946 minus 7 inches FCD sine of 70.946 degrees. Now I do realize that I have a bit of a typo right here. That is not 496, that is 946. 946. Feel free to pause the video at any point if you get lost. Write stuff down, look what I did, and catch back up. I'm going to be moving right along though, because this is a decently long problem, but I've got a longer one waiting. Simplifying this moment equation down, we get 93 pounds times 16 inches cosine 50 minus 4CD sine 70.946 times 7 inches. Solving for force CD, we get 144.56 pounds. So we answered part A. Now we move on to part B, which is finding our reactions at A and B. So I break this down in sum of forces X, Y, and Z, as well as a couple of them in component form, just because I need to break it up even further. So if we look at sum of forces in the X, the only thing that's going on is the AX reaction, but nothing else is going on to it, so AX is equal to 0. In the K direction, we have a negative sine 70.946 times force CD times 26 inches, which is perpendicular distance, plus 93 pounds times 13 inches, minus AY times 26 inches. Solving for AY, we get negative 90.14 pounds. Starting it in the j direction this time, we're going to have cosine 70.946 times 4 CD times 26 inches plus AZ times 26 inches is equal to 0. Solving for AZ, we get negative 47.2 pounds. Now that we have our AY, AZ, and AX, we can do sum of forces in the Y and the Z direction without doing it in IJ or K components. We get negative AY plus sine 70.946 times 4 CD minus 93 pounds plus the force BY is equal to 0. Solving for BY, we get 46.5 pounds. And then for our forces in the Z direction, we get negative AZ plus cosine 70.946 times FCD plus BZ is equal to 0. Solving for force BZ, we get 94.2 pounds. So that problem, I probably went a little quick for you to see it as, because that moment equation can get kind of tricky. So feel free, write it down, pause the video, break it each point down and see where I'm getting all these points from and all the simplification, and then you can follow it just fine. Forcing the acceleration in the K and J directions can also get kind of confusing, but just remember that that Planck is at an angle. That is why I broke it up in those different forms, just to get there. So that one is a 3D problem from chapter 4. It's a really good problem. So just kind of watch out for it. Take your time on these 3D ones. Taking your moments. Take your time. If you try to rush yourself, you're going to make mistakes. So please feel free to take your time. If you have any questions, feel free to email me. This is for the fall semester of 2020. Other than that, thanks for watching.